Welcome to Math 120, Intermediate Algebra. This goes for Doña Ana Community College and New Mexico State University. Using Turner-McKeague's Intermediate Algebra First Edition in Chapter 1, Real Numbers and Algebraic Expressions. Today I'm going to talk about Section 1.4, Exponents, but I'm going to leave scientific notation out of it. It's beyond the scope of this course, and so we're going to skip it. So, properties of exponents. As I mentioned in a previous lecture, the order of operations, PEMDAS, is very helpful in other areas as well, not just simplifying expressions. And here, I show you one of those uses. So the product property. If A is a real number, and R and S are integers, so integers, positive and negative counting numbers along with 0, then A to the R power times A to the S power is A to the R plus S. We might say that multiplying two things with the same base, we add their exponents. And multiply two things with the same base, we add their exponents. Check it out. In our order of operations, parentheses, exponents, multiply and divide on the same level, add and subtract on the same level. If we multiply two things with the same base, we step down and we add the Also, the quotient property. If A is any non-zero real number, and R and S are any two integers, then A to the R divided by A to the S, we subtract the exponents. So if we're dividing two things with the same base, we'll subtract their exponents, the numerator exponent minus the denominator exponent, and check it out. Division turns into subtraction of exponents. So the order of operations helps us remember what that operation should be next. The power property, this completes what I call the big three. We have the product, the quotient, and the power property is our big three. If A is any real number and R and S are integers, then if I have a power, A to the R, the exponent is R. If a power is raised to a power, I multiply. But what is a power raised to a power? That's an exponent. So if I have an exponent raised to an exponent, it steps down one on our order of operations and we multiply. The rest of the properties, still very important, not part of the big three. They don't necessarily go along with my PEMDAS model, but they're very important. If A and B are any two real numbers, and R is an integer, then if I have AB multiplied together, R times, then that's A to the R power times B to the R power. So we say that the property of exponent distributes over multiplication. Negative exponent. If A is any non-zero real number and R is a positive integer, if R is a positive integer, so it's not zero, it's not negative, it's a positive integer, then A to the negative R, that negative is a direction sign and it says move it across the fraction bar. So a negative exponent moves across the fraction bar to make it a positive exponent. Just like we had a distributive property over multiplication, we have a distributive property over division. If A and B are any two real numbers raised to the R power, then that's the same as A to the R divided by B to the R. Very important that B can't be zero because remember, no zeros in the denominator. A couple more properties of exponents. The identity property. If A is any real number, A to the first power is always A itself, right? If I have A and I multiply it by itself one time, that's weird, so it's A. Zero exponent property, if A is any non-zero real number, then A to the 0 equals 1. I say this as anything to the 0 power is 1, except possibly 0 itself. If you want to know what 0 to the 0 power is, take calculus. Great little property there. If you want extra practice on exponents, you want to see a few more properties and how they're used, my website contains a little extra practice for you. www.math.utep.edu/faculty/TuesdayJ, that's me, /algebra/exponents.pdf. I have a description along with several practice problems and answers to those practice problems.